Hello, today I will explain a lesson in AP Chemistry class which is Gibbs free energy. But first, I will introduce myself. Hi, I am Shahad Nashat Salim from Dubai National School Al Tuwar. I am a 12th grader and I take an AP Chemistry class. Before the end of this class, you will understand what enthalpy is and what positive and negative enthalpy mean. You will also understand what entropy is and what positive and negative delta S mean. You will be able to differentiate between spontaneous and non-spontaneous reactions. You will also understand what Gibbs free energy is and what positive and negative delta G mean. Finally, you will be able to solve 3 different questions that are all about Gibbs free energy. Let's start with introducing the Gibbs free energy equation. The equation is the following: delta G equals delta H minus T delta S. As you can see here, we have delta G, delta H, and delta S. You might not know what they refer to, so I will explain them in the following slides. Let's start with enthalpy, which is delta H. It is the measure of the total heat present in the thermodynamic system. You might be familiar with 2 types of reactions: exothermic reactions and endothermic reactions. Let's start with exothermic reactions. Here we have a system. This is the system. And we also have surrounding. In exothermic reactions, the system releases energy. It releases heat, and as a result, the system becomes cooler. Now let's talk about H final and H initial. In exothermic reactions, the system releases energy. It started with a lot of energy, but then it released this energy, so it ended up with having less energy than what it started with. So H initial is greater than H final. How do we find delta H? We find delta H, we do H final minus H initial, and if H initial is greater than H final, we will end up with having a negative delta H. So we can conclude that when delta H is negative, the reaction is an exothermic reaction. Let's move on to endothermic reactions. Here again we have a system. And we have a surrounding. In endothermic reactions, the system absorbs energy. It absorbs heat from the surrounding. And as a result, the system ends up being warmer than its initial temperature. Let's talk about H final and H initial. The system didn't start with a lot of energy, so its H initial is small, but H final is large since the system absorbed energy. So H final is greater than H initial. And how do we find delta H? Again, delta H is H final minus H final minus H initial. H final is larger than H initial, so delta H here is positive, and we can conclude that when delta H is positive, the reaction is an endothermic reaction. We're done with delta H. Now let's move on to delta S. Delta S is entropy. Simply, it is the degree of randomness of a substance. It is the degree of randomness of a substance. Let's talk about the 3 states of matter: solid, liquid, and gas. As we move on from solid to liquid to gas, what happens to the particles? In solid, the particles are close to each other. They are organized. How about the randomness in solid? There's no randomness since the particles are organized. They are close to each other. But in liquid, there is more randomness since the particles are moving more here than they did in solid. And gas, the randomness is a lot, since the particles are moving a lot. So entropy is increasing as we move from solid to liquid to gas. But what if we moved at the opposite direction, from gas to liquid to solid? What happens to randomness? Randomness decreases since particles become closer to one another. So here we have a negative delta S, or a decreasing entropy. We're done with delta H and delta S. Now let's move on to spontaneous and non-spontaneous reactions. Let's relate them to real-life examples. For example, a ball is moving downhill. Let's talk about energy here. Does the ball need an input of energy to move from a higher area to a lower area? Does it need any person to push it, or does the ball move by itself downhill? Energy is not needed here. Let's look at the other scenario. The ball is moving uphill. Does it need an input of energy, or does the ball move by itself up the hill? Do we have to push the ball, or does it move naturally up the hill? Of course, it needs an input of energy. Yes, energy is needed. Let's look at other examples. For example, rusting. In rusting, iron is exposed to oxygen, and oxygen reacts with iron, so the iron rusts. Does iron need an input of energy to rust, or does it rust when it is exposed to oxygen? No need for energy here in the example of rusting. Whereas in boiling, even the picture, we have an input of energy. Water does not boil by itself. It needs an input of energy. So yes, energy is needed. What do we call a reaction that does not need an input of energy? We call that reaction spontaneous reaction. And what do we call a reaction that needs an input of energy? We call the reaction a non-spontaneous reaction. We talked about delta S and delta H. We also talked about spontaneous and non-spontaneous reactions. Now let's relate all of them together by answering this question. Describe the following as spontaneous, non-spontaneous, or cannot tell, and explain. A reaction that is exothermic and more random. Is it spontaneous or non-spontaneous? How do we answer this question? If we want to answer this question, we have to memorize this table that relates delta H with delta S and delta G, which we'll talk about later. You have to memorize this table to answer this question, but if you hate memorizing, I can give you a fun way to solve the question. We can start by drawing the following figure. Here is positive delta H. Here is negative delta H. Here is positive delta S. And here is negative delta S. Okay? Now, this figure will help us to relate delta H with delta S, but that is depending on the sign. If delta H is positive and delta S is negative, here we have a non-spontaneous reaction. But if delta H is negative and delta S is positive, we have a spontaneous reaction. Now, what happens when delta H and delta S are positive, or when delta H and delta S are negative? What happens here? Here we cannot determine whether the reaction will be spontaneous or non-spontaneous. The temperature should be given. When both values are positive, the reaction will be spontaneous at higher temperatures. But if both values are negative, then the reaction will be spontaneous at lower temperatures. This is our figure, and it is a fun way to answer the following questions. Now let's draw the figure again. here's positive delta H, here's negative delta H, here's positive delta S, and here's negative delta S. Here's non-spontaneous, here's spontaneous, here's spontaneous at high temperatures, and here's spontaneous at lower temperatures. Okay, the first case is exothermic, so we have negative delta H, and it becomes more random, so positive delta S. What do we get when we match negative delta H and positive delta S? We get spontaneous. So A, we write spontaneous. Now B, exothermic, so negative delta H becomes less random, so negative delta S. Delta H and delta S share the same sign, so here we cannot determine whether the reaction will be spontaneous or non-spontaneous. We have to have the temperature, and temperature is not given, so we write cannot tell. Moving on to the third question, endothermic, so positive delta H, and becomes more random, so positive delta S. Both values share the same sign, so again we cannot determine whether the reaction will be spontaneous or non-spontaneous because temperature is not given. Let's look at the final scenario, endothermic, so positive delta H, and becomes less random, so negative delta S. They don't share the same sign. So let's look at the figure. Positive delta H is here, and negative delta S is here, so the reaction will be non-spontaneous. Now explain how temperature affects your answer. Temperature affects my answer at the second question and the third question. When both values are negative, the reaction will be spontaneous at lower temperatures, whereas when both values are positive, the reaction will be spontaneous at high temperatures. And we're done with this question. We're done with delta H, delta S, and spontaneous and non-spontaneous reactions. Let's move on to delta G. Again, the equation is delta G equals delta H minus T delta S. Delta G here is Gibbs free energy, which is the energy available to do work. Delta H is enthalpy or heat. T is temperature in Kelvin. Make sure that the temperature in Kelvin. And delta S is entropy. Okay? The units will be different when you answer questions. For example, delta H might be given in kilojoules, whereas delta S might be given in joules per Kelvin. Here's kilojoules and here's joules, so you have to convert either joules into kilojoules or kilojoules into joules. And temperature should be in Kelvin. So if, for example, the given was 10 degrees Celsius, you change that into Kelvin by adding 273. So 10 plus 273 will give us 283 Kelvin. In the same way that enthalpy had positive and negative delta H and entropy had positive and negative delta S, delta G also has positive and negative delta G. Let me tell you that positive delta G represents non-spontaneous reactions, whereas negative delta G represents spontaneous reactions. How is that? You can relate positive delta G to positive delta H positive delta H, and negative delta G to negative delta H. Now what happens when delta H is positive? Delta H is positive when the reaction is an endothermic reaction. And what happens in endothermic reactions? The system absorbs energy. So the reaction needs an input of energy in order to proceed, which tells us that this reaction is also a non-spontaneous reaction. What about a negative delta H? When the delta H is negative, we know that the reaction is an exothermic reaction where the system releases energy. So the reaction does not need an input of energy to proceed, which tells us that the reaction happens by itself, so it is a spontaneous reaction. Also, when delta G is larger than 0, the reaction, delta G is positive, so the reaction is non-spontaneous. When delta G is less than 0, which means that it is negative, it means that the reaction is spontaneous. When delta G equals 0, the reaction is at equilibrium. Now we're done with delta H, delta S, spontaneous and non-spontaneous reactions, and delta G. Let's move on to solving questions. A reaction at 25 degrees Celsius has delta H of 180.7 kilojoules and delta S of 24.7 joules per Kelvin. Calculate the value of delta G. Is the reaction spontaneous under these circumstances? Now let's write the given. We have temperature, which is 25 degrees Celsius. We also have delta H, which is 180.7 kilojoules. We have delta S, which is 24.7 joules per Kelvin, and delta G is unknown. Let's take a look at the units. Temperature is in degrees Celsius, and we know that temperature should be given in Kelvin. So we add 273 to the value. 25 plus 273 gives us 298 Kelvin. Delta H and delta S. Delta H is given in kilojoules and delta S is in joules. You can convert kilojoules into joules or joules into kilojoules. Personally, I like to convert joules into kilojoules, so I divide 24.7 by 1000 to give me kilojoules. We have our values. Now let's plug them in the equation. Delta G equals delta H minus T delta S. Delta G equals delta H 180.7 minus temperature, which is 298 Kelvin, and delta S is 24.7 divided by 1000. Multiply both numbers, then subtract 180.7 minus that value, and you will get delta G equals 173.3 kilojoules. Okay? And the question also asks if the reaction is spontaneous under these circumstances. We know that the reaction is spontaneous when delta G is negative. And what we found is that delta G is positive, so no, the reaction is non-spontaneous. Okay? Now moving on to the second question. Calculate the standard free energy change for the below reaction at 25 degrees Celsius. And we have the reaction. Now they want us to calculate the standard free energy change. What is that? To calculate the standard free energy change, we have to use this equation. Don't panic, it is easy to solve. Delta G arcs N and delta G F. What is delta G arcs N and what is delta G F? Delta G arcs N is here. It is the standard free energy of reaction, which is the free energy change for reaction when it takes place under standard state conditions. What about delta GF? Delta GF is the standard free energy of formation. It is a free energy change that takes place when 1 mole of the substance is formed from its elements in their standard state. To solve this question, we can write this reaction in this form, where the lowercase letters represent the number of moles and the uppercase letters represent the substance. To solve this question, we find delta G arcs N. How to get delta G arcs N? We get it by finding the geoformation for the products minus we find the total geoformation for products minus the total geoformation for reactants. Let's solve the question. The reaction is CH4 plus 2O2 will give us CO2 plus 2H2O. We need to find the delta G formation for each one of the reactants and products. So our equation will be delta G reaction equals G formation for products minus the reactants. These are products and these are the reactants. So G formation for carbon dioxide plus 2, since we have 2 moles of water, 2 geoformation for H2O. We add the values together for the reactants and we're done with, for the products I mean, and these are the products. Now we minus geoformation for the reactants, so CH4 plus 2, since we have 2 moles of oxygen, 2 geoformation for oxygen. That's our equation. Also, to solve this question, we need to have a table that tells us the geoformation for the substance. As you can see here in the table, carbon, hydrogen, nitrogen, and oxygen all have a geoformation of 0. Why is that? It is because these elements are in their standard form. They are in their most stable form. So when you see any substance that is diatomic, you know that the geoformation is 0. Now we need to plug in the numbers from the table. So delta G arcs N equals geoformation for carbon dioxide. Carbon dioxide is here. It's here. So negative 394.4 plus 2 for water, but we have 2 water here. Which one do we use? We use the value that is based on the state of water. Here it's in here the water is in gas, which is water vapor, and here it's in liquid form. The question asks us for water in liquid form, so we use this value, which is negative 237.2. And why did we multiply the value by 2? Because we have 2 moles of water. We have 2 moles of water. We're done with the products. So we minus now the values for the reactants. Geoformation for CH4. CH4 is here. The value is negative 50.8. Plus 2 G of F, G2 GF for oxygen, and oxygen is 0, so no need to add it in the equation. We found the values. Now let's use a calculator to find the value of delta G arcs N. You must get negative 818 kilojoules per mole. And we're done with this question. Let's move on to the last question. Identify which of the following graphs represents an endothermic reaction and which represents an exothermic reaction. Let's start with the graph that is to the left. The y-axis gives us the energy, and the x-axis gives us the reaction coordinate. A plus B are the reactants, and C is the product. To solve this question, we have to compare H final with H initial. H initial is here, since this is the energy of the reactants. This is the energy that we started with. And here's H final. This is the energy of the products. H final is almost here. This is H final, since it is the energy of the product, and it is the energy that we ended up with. As you can see, H final is greater than H initial, which means that the system gained energy. It didn't have a lot of energy at first, but then it gained energy. So this is an endothermic reaction. Okay, we'll do the same thing to the graph that is to the right. A plus B represents the reaction, the reactant, and C represents the product. H initial is here. It is the energy that the system started with. And H final is almost here. It is the energy that the system ended up with. Let's compare H initial and H final. H initial is greater than H final, since H initial is here and H final is here, which means that the system had a lot of energy, then it lost some of this energy. So the reaction is an exothermic reaction. Okay, we're done with the last question. At the end, I'd like to thank you for your time and attention today. Again, I am Shahad Nashat Salim from Dubai National School Al Tawar. I had fun explaining this AP Chemistry lesson, and I hope that you enjoyed it too. Thank you for your time. Bye bye.